Hello, Lani. I hope you're all right. This is Harrison from New Year's Paving and Building Contractors, a division of audio project. Okay, I thank you so much for the opportunity you gave me to actually come and have a look for the problem, what happened to the damage due to the storm water. But also, I think the problem also had to do with improper construction and inferior materials. That also all those things they played part to actually that led to the collapse of the wall. Okay, but now what we propose now is permanent solution. So what I've just decided to do as a contractor uh, is to sort of do a little bit of drawing and then just to give you an insight that this is the solution to fix this problem because this is what we do all the time, right? So we have experience and the knowledge, right, that is needed to build something that is gonna last. Because now you see, if I was the contractor who built this wall, I would have recommended these blocks and I would have built it in another way because those blocks they don't form a strong wall because of their shape and design. They don't lean at 70-degree angle into the back. They easily sort of get pushed over and they don't lock, and the weight, they don't have any weight, so they are light, so the retaining wall has to be heavier than the bank. So all those things that I'm mentioning right now, that's what led to the collapse of the wall. So we are the contractor that knows the solution, right? How to fix, how to build a structure that is gonna be resilient to these disasters. So okay, we've had so many bad rains that have affected homes, and we now actually sort of able to actually sort of we've come up with innovative ways to sort of raise structures that are gonna be you know uh, resilient to just in case something like this happens again. Okay, so what I'm gonna do is I'm just gonna sort of this is the design of the wall now. This is like its shape. It's basically the shape. So what I'm gonna do now? I'm gonna do another drawing that is gonna have all the specifications, structural engineering specifications, right? And then I'll present that to you. Okay. So just give me a few minutes and then I'll be right back. Okay, Lani, welcome back. So what I've done is I was sort of to try to label the structure of this wall, but there's gonna be another actually sketch up. All right. So, but if you what I wanted to sort of you know emphasize and sort of highlight and explain further is probably that this is gonna be the gravel layer. All right. Because the good thing about this drawing is in 3D. All right. So basically, if you can see clearly, this is gonna be the wall, all right, with its design because that's the shape of the existing wall, but this one is gonna be the new one now, right? So this is the raw force line. These are the retainer blocks. We call that a dry stick segmental retainer, all right? So this is gonna be the layer now of the gravel because gravel is when it's compacted, it stays in place for forever. It doesn't sort of like expand and sort of when it's damp it expands and loosen up. It stays firm in place, right? So yeah, basically that is actually the presentation of this. Then we are gonna be sort of compacting all this on-site excavated sand or material. We normally call that in situ material in construction. All right, materials that are on site, we call them in situ materials, like earth or excavated anything from the ground. Okay, so this is actually the layer that we're gonna have to compact around, right? So all this is gonna get compacted, right? If this is stable and the gravel is stable, then there is no chances that the wall is gonna get affected because what happens is what actually behind this, that what causes the failure. All right, it's got nothing to do with it's actually the compaction. Compaction is the most important thing, right? And then the other factors that also is the leaning. It should lean at 70. You see that existing wall that that wall that collapsed. Those blocks and the way it actually sort of gets elevated or get erected is it doesn't form that 70-degree leaning into the bank, right? I will also present that just now. Okay, so the most important thing again, before I sort of close up this this drawing here, okay, is what you're gonna have to do about the top part after completely finishing the project. We need to think about, okay, water, if water comes again and washes off this, what's gonna happen. You see, we need to actually sort of, if we pave this or cement it or put pavers or we put asphalt, which is also known as tar, whatever material you wish to pave, but this area has to be paved, and it has this side here towards the wall, it has to be elevated slightly so that the gradient, it comes towards this where there is an existing boundary precast wall, right? Right, it should actually sort of slope towards that area, and then we're gonna have to install these drainage systems, pipes, and connect to the existing line there with those manholes, right? So that's the most aspect of this project. Okay, so now what I'm gonna do now is actually to do another cross section of sort of the layers, but this has actually sort of highlighted all the aspects of this project and all the elements that have been mentioned in the code. Okay, so yeah, I'll be right back. Okay, Lani, so you see, that's what I've just been drawing all this time, because this is the most important aspect. This is the most important aspect of this specification. So basically, this is how we're gonna be building up. So number one, I would like to mention that as the wall goes up, it goes at 70 degrees. This is how you lay a block, you lay another one, you lay another one, you lay another one. You see, can you see that? You see, we are actually moving a distance from the vertical line, right? Can you see that? So this is how actually the wall goes up until we reach the top, right? And then the rest now, I'm just gonna show the layers of the drainage, the backfill gravel, and the excavated material. Okay, so I'm just gonna spin it all the way until I get to the top. Okay, all right, there we are. So in civil engineering or in construction, these are some of the issues that are very important. This is actually any specification that is done universally, globally, across the whole world, as far as the construction of a dry stick segmental retaining wall. Okay, so these specifications, they are not like sort of they are global. They are like applied by any contractor building something structurally in engineering, right? So the height is saying it's 4.5. In fact, it's actually going to be 4.5. It's actually 4 meters, 4.5 meters, right? All the way to the top. Okay, and then these are the blocks. Geolog 400. I'm just gonna label them. Geolog 400. Retainer block. Geolog 400. I don't know. Is it too far? Geolog 400. Manufactured by Coral Brick. Okay. And then this is the backfill gravel. Let me just speed it up because my recording parameter is 10 minutes. I'm just about to be due. Okay, so this is the backfill compacted gravel, G5, G7, but G7 we're gonna be using because it actually that's the most suitable material for backfilling, right? Backfill gravel, compacted to maximum density, right? And then there is a drainage. That's the drain pipe, the 110 UPVC agri drain pipe. PVC drain pipe, right? Okay, and then around it we're gonna put those 90mm stones. They should be like with the you should form about the diameter of about maybe 300 or 400, right? Stones, 90mm aggregate stones around the pipe, right? And then this is now this is gonna be the material from side, the excavated material that we're gonna have to compact, right? This is excavated material, right? And